Okay, this is Java math methods and casting. So in programming, sometimes you want to convert between data types, like converting from a double to an int, or the other way around. You can do this through casting. Primitive variables like ints, chars, and doubles have a precision ranking. Doubles have a greater precision than ints, and this makes sense because doubles can store more data than an int. So there are two ways to cast data types. One way is called implicit casting. The way it works is when you try to store a less precise data type into a variable with a more precise data type, that value will become the more precise data type. So that might have sounded confusing, but it's like if you try to store an integer in a double, the integer will automatically turn into a double and be stored like that. So as you can see here in the output, when both the integer and double are printed, they will give a slightly different value, 15 and 15.0. This is because the decimal num can only hold doubles, so the integer value that is being stored in it gets changed to a double, and this happens all automatically. And know that this only works when going from a less precise data type to a more precise data type. So you couldn't store 15.4 in an integer without losing accuracy. The other way to cast a data type is called explicit casting. In order to do this, you simply put the data type you want to cast in parentheses to the left of the original value. In this example, 15.0 is being casted to an int. 15.0 is a double, and 15 would have to be turned into an int because a double is a more precise data type and an int is less precise. So without the casting, this would create an error. Note that when you cast from a double to an int, it truncates the double. So this means that it only gives the number before the decimal point. So if decimal num was equal to 15.8 beforehand, then when you set it to int num will actually just store 15. It won't round like go up to 16, it'll just chop off everything past the decimal. So Java also provides built-in methods so you can perform more complicated math operations like square roots and finding the minimum of two numbers and rounding up or down. It also provides certain numeric values that you can use like pi. Pi is an infinitely long number and it will be very difficult to remember or type this in your program. So if you wanted to use it, Java allows you to automatically use it like a variable without having to manually create it. Now, one of the special ways to store data is through constants, which are like variables except they cannot be changed once they're originally set. They're useful for holding values that you know will not change. If we know a variable will not be changed, constants make it easier to keep our code organized. So for example, if you wanted to store the user's birth year, you could store it in a constant instead of a variable, because you know someone's birth year cannot change. Now, if you accidentally tried to change the user's birth year, later on in the program, you'd get an error, and it just makes sure that you don't change values that should always remain the same. So in Java, you can create constants the same way as variables, except you put the keyword final in front. Here's an example of creating an integer constant called minimum age to play. The convention in Java is to capitalize all the letters in the name of the constant, and to separate words we use underscores since we can't use camel case anymore. Just a reminder that constants work just like any other variable aside from the fact that you can't change the value. So in this example, you see that there's a constant called minimum age, which is the minimum age to play a certain game. Then you have the player age, which you'd likely get from user input, and we just set it as 11 here for simplicity. Now we can see if the player's age is less than the minimum age required to play, then the program prints, "You cannot play." So one important value in math is pi, which is used in concepts like the area of a circle. What do you think the variable declaration for pi looks like. Okay, so pi is a value that does not change, so it would be a constant. And because pi has a decimal, the data type would be a double. So the variable declaration in Java would look like this. You have your final keyword, which tells Java that this is a constant, and then you have double to tell the data type, and then you have the variable name, which is pi, and then you have all your values for pi. And obviously this is shortened because pi is very, very long. So, getting the absolute value of a number. Math.abs is a method that gets you the absolute value of a number, which is just the positive value of a number. So it basically removes the negative from your number if there is a negative, and if the number is positive, the method does nothing to it. There's one parameter, which is a number, and it can be either int or double. The method will return the same data type as you gave it in the parameter. So if you pass in 10, because it's an integer, the return type would be an integer. But if you passed in 5.8, the return type would be a double. So here we can see we have a negative integer with the value of negative 17. We create a new integer and set it to the absolute value of our first integer variable. When we print the new integer, we get the positive value of negative 17, which is just 17. So math.round rounds a number to the nearest integer. It only takes in a double parameter because you wouldn't need to round an integer because it's already rounded. So if the decimal value is less than 0.5, it rounds the number down. If the decimal is greater than or equal to 0.5, it rounds up. The method will return an integer. So in this example, we have a double variable equal to 31.3. Then we create an integer variable where we round the double variable, making it 31. Now what if you wanted to specifically round down or round up? Regardless of the value of the decimal, to round down you can use math.floor, which takes a double parameter and returns an integer. To round up, you can use math.ceil, which also takes a double parameter and returns a double. Sorry, it returns an integer as well. And so here we have 14.4, which when rounded down will be 14, and when rounded up it'll be 15. So if you have two numbers and you want to find the larger or smaller number, you could use an if-else statement to figure it out. But that's extra work. So instead, you can use the Math.max or Math.min methods. These methods take two numbers and they return the larger or smaller number depending on which one you use. You can use doubles or ints in the method, and it'll return the same data type that you put in. So in this example, we have Johnny age, which is equal to 13, and Sally age, which is equal to 14. And we create a new integer variable called younger kid, and we just want to get the age of the younger kid. So we'd use Math.min, and we'd pass both of our integer variables into the method, and we'd get back 13. Now for exponents, Math.pow allows you to use exponents, which are just an easy way to do repeated multiplication. It is two double parameters. The first one is the base, and the second one is the actual exponent. You can't flip these because the parameters must come in this order, and if you flip them, Java will get confused. The method returns a double. The first parameter, which is the base, is the number you're repeatedly multiplying. The second parameter is the amount of times you want to multiply the base by itself. So if we had 3, base 3, exponent 3, it would be 3 to the power of 3, and we'd have 3 multiplied by 3 multiplied by 3, which would get us 27. And so the same way, if we had 2 to the 5th power, the way we use it in Java is Math.pow, and then our first parameter would be 2, and our second parameter would be 5. And what we'd get back would be 2 times 2 times 2 times 2 times 2, which would be 32. Now, if you want to get the square root of a number, you can use the Math.sqrt method. It's just a fun way to say it, just SQRT. And this takes a double as a parameter, and it returns the square root of whatever you give it. So we start off with an integer variable, which is 25, and you'll see that we pass that integer into the square root method, even though the method requires a double. This is an example of implicit casting. The method takes the integer and automatically casts it to a double, which is greater precision, so it's allowed. And then the method does whatever it's supposed to do. And finally, it returns a double, but if we wanted to store that value in an integer variable, we would need to explicitly cast it as an integer because you're going back to a lower precision data type. So in the end, the integer variable square root has the value of 5 right here. And as you can see, there's both types of casting, both implicit when you pass it into the method and explicit when you're taking it and storing it in the variable after it's returned. Now, if you want a random number, you can use the math.random method. It has no parameters and it returns a number greater than or equal to 0 and less than 1. So it could be from 0.0001 all the way to 0.9999. And you can manipulate this value to get a different range of numbers. So, for example, if we wanted to generate a random number from 0 to 10, we could just take math.random and multiply it by 10, which would generate, so for example, if the random number was 0.15, after multiplying that by 10, you'd get 1.5, and when you cast it to an integer, you'll just get 1. And let's say we wanted to get a random number from 5 to 15. Now you still have a range of 10 values, so you'd still multiply by 10, and then after multiplying, you would add 5. So let's say the math.random was 0.23. After multiplying it by 10, we'd get 2.3, and then we'd add 5 to it, so we get 7.3, and because it's cast to an integer, we'll just get 7. So now we have some exercises. Here's exercise 1. You want to create a method called max3 that finds the maximum of 3 numbers. So it's kind of like Math.max, except you have 3 numbers now. Okay, we have exercise 2, which is to recreate the Math.pow method in a new method called Exponent. And it should work exactly the same way. And this should just be for practice. And exercise 3 is create a method called n-sided die that simulates the rolling of a die with n sides. So it should return a random integer in the range of 1 to n, and since you're doing n-sided die, then you're going to need a parameter which would be n, and that'll be an integer. And we have exercise 4, which is a bit of a challenge. You want to create a game where the player has to guess a random number from 1 to 100, and each guess they're told if the random number is higher or lower than their guess. Once they guess the number, tell them how many guesses it took. So in the beginning, you want to create your guessing number, so you randomly generate a number from 1 to 100, and then you keep that the same throughout the game, and you repeatedly ask the player to guess a number, and then they might guess 50, and let's say your random number is 78. So then you'll tell them your guess is too low, and then they might guess 75, and it'll still be too low, and they might guess 80, and then you'll say it's too high. And at each of these guesses, you want to increment like some sort of count variable, so that at the end, you can say it took you this many guesses. And once they guess 78, you can say, congratulations, you got it. And as a challenge, a further challenge, you can also have it so that once the player guesses the number, you ask, do you want to play again? And if they say yes, then it automatically runs the game again with a new random number. Okay, so that's all for today's class on math methods in casting. Once again, if you need any help on the exercises or you just want help or further explanations, you can join our Discord channel in the description. And that's all.